Hello dear students, good evening to all of you guys. So in this particular daily dose, we will discuss about the deflection criteria which is recommended by IS 456. So you know that guys, while assuming the value of effective depth in our beam, we need to take care of the deflection also. So as per the IS 456, you need to satisfy the deflection criteria, right? Then only that particular depth can be suitable for the beam part. Okay. So this particular criteria we will discuss in detail, guys. Let us understand what it is exactly. So as per IS 456, what they have recommended, let us suppose if the span of beam is less than 10 meter, then there is one ratio which is basically span upon effective depth ratio, right? Span upon effective depth ratio, and it should be less than or equal to what? A value. It should be less than or equal to what? A value. Now on the basis of this criteria, we are able to assume the value of D, or we are able to calculate the value of D which is required so that our beam should be safe in the deflection, right? Now what are the various A value we have? Let us understand. So for cantilever beam, A value will be 7. For simply supported beam, it is 20. And for continuous beam, it is basically 26. So these are the value which is recommended by IS 456 for these type of beam when their span is less than 10 meter. Now let us suppose, guys, if I change the span and our span value is greater than 10 meter or it is equal to 10 meter, right? If our span is greater than or equal to 10 meter, then in such condition your A value will get changed or our A value will get modified. Now the modification factor which we need to apply here is 10 by span value, and the span value should be in meter. So you need to multiply the A value by this particular parameter. So our formula will become like this: span by D is less than or equal to A value multiplied by 10 by span. But please remember, guys, this particular criteria is only valid, or this particular modification factor is only valid when you have cantilever, when you have simply supported and continuous beam, right? For simply supported and continuous beam, it is not valid in case of cantilever part. Okay, so please remember this one. Up to this, I think it is clear to all of you. Now guys, there are certain modification factor which is based upon the tension reinforcement, compression reinforcement, and if you have a flange beam, then there will be a one reduction factor, so that we will also discuss. Okay, so let us understand, if our percentage of steel is given to us, or that means AST is known to us, then in such condition we can change our value of A, and that A value will get modified as per the modification factor 1. So let us understand how we can calculate it. So first of all, guys, this is basically percentage tension reinforcement, right, on the x-axis. This is basically PT. Now how we can calculate it? It is very easy. We have to write AST divided by B into D and multiply by 100. You will get the percentage of tension reinforcement. Now there is one value, guys, which we need to calculate. That is basically Fs value. And Fs is equal to 0.58 Fy multiplied by AST required. How much AST is required? And what is the value of AST which you have provided, right? You need to take the ratio of it and multiply by 0.58 into Fy. You will get the value of Fs. Now after knowing the value of Fs and after knowing the percentage of tension reinforcement, what you have to do, let us suppose, guys, our Fs value is 240 and our PT value is 1.6. Okay, so I will project this particular point in vertical direction like this, and whatever intersection point is there on Fs is equal to 240 right now, because our assumption is Fs is equal to 240, we'll try to project it over here. So in this way we are able to get the value of what? Modification factor 1. And this modification factor 1 you need to apply in our formula. Clear? So our formula will get changed. Let us write it down again. Span by D is less than or equal to what? A value. Then A value multiplied by 10 by span, and then it is multiplied by modification factor 1. Clear? Now similarly, guys, we have another modification which is based upon the compression reinforcement. Okay, let us suppose if percentage of compression reinforcement is known to us. So percentage PC is equal to what? ASC divided by B into D and multiply by how much? 100. In this way, you can calculate the percentage compression reinforcement. Let us suppose right now it is 1%. So I will project it like this, and then you have to project on the y-axis where you will get the modification factor 2, right? So this will be our modification factor 2. Now our formula again will get changed and it will become span by D less than or equal to A value multiply by 10 by span multiply by modification factor 1 comma, or you can say that cross multiply it modification factor 2. So this is our next formula, right? Or you can say that this is our formula in which we have included all three conditions when the span is greater than 10 meter, modification factor 1, modification factor 2. Now this particular formula can be valid in case of a rectangular beam, but guys, most of the time we may have the T-beam also. So in such condition, we have another factor which is known as reduction factor. So how we can calculate? It is very easy. Let us suppose this is your T-beam. So there are basically two width. One is web width. This is our web part. So BW, and this one is flange width. So BF. So you need to take the ratio of BW by BF first. Find out the ratio of BW by BF, and this ratio is written over here. BW by BF. Okay. Now let us suppose right now we are getting BW by BF is equal to 0.8. Oh, sorry, 0.6. Okay. Now we will project it, and then again we will get what? We will get a reduction factor. Now again this reduction factor should be multiplied with respect to our A value. This is our RF. Now our formula will be what? Span by D value less than or equal to A value less than or equal to A value and multiply by 10 by span multiply by modification factor 1 multiply by modification factor 2 and multiply by reduction factor Now I hope all of you are able to understand, guys, this particular formula, which is very, very simple to calculate the effective depth which is required to save in deflection, right? So I hope this is understood to all of you guys. But remember this formula is valid only in case of what? T-beam. And the previous formula which we have discussed, in which there is no reduction factor, so that formula is valid for our beam condition. Okay. So this is all about for today, guys. I hope you have understood the daily dose video today, right? Let's discuss some other concept in another video, right? Bye bye, guys. Take care and thank you so much.